Which of the following atoms is not paramagnetic? A. Sodium, B. Magnesium, C. Carbon, or D. Titanium? Paramagnetism is due to unpaired electrons. Obviously, an atom will have an unpaired electron if it has an odd number of electrons. This is the case for sodium. If we refer to a periodic table, we'll find that sodium has 11 electrons. In general, an atom will have at least one unpaired electron if it has a partially filled subshell. So let's examine the other choices given here. Magnesium has 12 electrons. Its electron configuration is 1s2, 2s2, 2p6, 3s2, or neon core 3s2. Carbon has 6 electrons. Its electron configuration is 1s2, 2s2, 2p2, or helium core 2s2, 2p2. Titanium has 22 electrons. Its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2, or argon core 4s2, 3d2. Recall that an s subshell is completely filled by 2 electrons. The s subshells highlighted here are completely filled. Now a p subshell is completely filled with 6 electrons. Therefore, these are completely filled. But this one is not. A d subshell is completely filled with 10 electrons. Therefore, the 3d subshell in titanium is not completely filled. Therefore, we can see that of the choices given here, only magnesium has completely filled subshells. All the choices given are paramagnetic except magnesium. The correct answer is magnesium. You might ask, why does a partially filled subshell imply that there is at least one unpaired electron? In the case of the s subshell, it's obvious. If it has one unpaired electron, it's only half filled. If it is completely filled with 2 electrons, then there is no unpaired electron. Other subshells, it has to do with Hund's rule. Hund's rule says that to get the ground state or most stable state of the atom, when filling subshells with more than one orbital, they must be filled singly with electrons of parallel spin. Consider iron, which has an electron configuration of argon core 4s2, 3d6. Even though it has an even number of electrons, it actually has 4 unpaired electrons in the 3d subshell. Recall that the 3d subshell consists of 5 orbitals. With only 6 electrons, the subshell will be partially filled because it can accommodate up to 10 electrons. Hund's rule says that to get the ground state configuration, we need to fill in these orbitals singly first. So the first 5 electrons will go here, 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 and here. Note that all the spins are parallel. Now the 6th electron will go to any one of these orbitals, but it must be of opposite spin as required by Pauli's exclusion principle. It can go here, or here, or here, or here, or here. In any case, there are 4 unpaired electrons, and we expect iron atoms to be paramagnetic.